Very good morning to all. In this presentation, we are going to see about the convection and types of convection and forced convection. Let me see one by one. So the topics discussion in this presentation is introduction to convection, identifying the forced convection, Newton's law of cooling, drivers of the forced convection, the heat transfer coefficient H. The sketch itself indicates the forced convection with the fan and the natural convection which happens naturally. The hot egg is kept at the floor. Let me see the concept one by one. Introduction to convection. It has a definition. Convection is the transfer of heat through the physical movement of fluid. We know that fluid to fluid or metal to fluid is the convection. Transfer of heat from the fluid to fluid or metal to fluid. We know the gas, liquid, vapor, all are fluid. So the key concept, it combines the effect of conduction and advection, bulk fluid motion. Here the sketch represents that force convection. The force is given here. The natural convection, it happens naturally. The conduction, which is happening from the metal to metal, which exhales, trying to exhale. That's why the convection is happening. So we keep it all in mind always that the convection never happens alone. It always happens in combined effect of conduction and convection. Let me come to the next slide. So identify the force convection. Here in this sketch we can see the fan is here, which is giving the fluid force of the cold air. The hot surface is here, which is observing the heat. The T2 we can see. After observing all the heat becomes T3, which is hotter. So the core mechanism here is unlike natural convection, which relies on the buoyancy force convection uses as external force to move the fluid. So the primary drivers are fans, pumps, blowers, or even the wind. They act as the force convection that is depicted in this picture. So I thank the resource heatpipe.com site. I have taken these sketches from there. Coming to the next slide. The Newton's law of cooling is a very important law in the convection point of view. So the rate of heat transfer is calculated using the formula Q equal to HA delta T. Q is heat transfer, H is heat transfer coefficient, A is the area, cross-section area, delta T is the temperature gradient. So this is the Newton's law of cooling invented by the Newton. So let me go for the next slide. Before that, I thank google.com for giving these pictures and acknowledge all the resources which I observed for this presentation. So the heat transfer coefficient H is very important concept in this heat transfer. In forced convection, the value of H is significantly higher than the natural convection. It is indicated by the unit watts per meter square Kelvin. The coefficient is influenced by fluid velocity, turbulence, and the physical properties of the fluid that we can see in this simple sketch. So going to the next slide. Drivers force of convections are fans, pumps, blowers, and suction system. This we had seen already. Coming to the next slide, external flow dynamics, we can see a plate is there, over that fluid is flowing. This is called external flow. Its dynamics shown occurs when fluid flows over the unconfined object. Example, airflow over vehicle or cooling fan. This is the example. Coming to the internal flow dynamics, inside the tube, the fluid is going, which is absorbing heat, then it becomes hotter. Its dynamics is shown here, which having the major application HVAC system, heating, ventilating, and air conditioning system. Coming to the next slide, cooling in modern electronics. We know the electronic cooling is major challenge to all the electronic gadgets. Every day, new model of mobile phones and tabs and laptops are coming. It has the problem of dissipating the heat. So that heat can be dissipated through the new technologies called modern technologies of heat exchangers, and electronics cooling is very important concept under that way. So force convection is virtual thermal management computer. Yes, and electronic gadgets also. CPU fans are forced they are remove the heat sink to prevent the hardware damages. It also improves the efficiency. Coming to the assessment question, what is the defining characteristics of force convection? The answer is option C. fluid motion is produced by an external source like a fan or pump. Already we have seen in this presentation. Which of the following would be an application of force convection? Which is nothing but option B. Which of the following would be an application of force convection? Application: water pump, circulation coolant through a car engine, warmer rising from cup of coffee, metal spoon getting hot in the fuel, then sun heating prevent. Already the water pump circulating the coolant through the circulating pump. So with this small presentation about the convection, I are using these as references. I thank everyone.